The Pulse School on RealAgriculture.com is brought to you by BASF.
For Real Agriculture, I'm Kelvin Hepner at Crop Connect, and we are talking about root rots in pulse crops and where things are headed on the research front. We're joined by Daryl Domitruk, Executive Director with Manitoba Pulse and Soybean Growers. And Daryl, we have recently seen announcement of the new Pulse Research Cluster under the new Sustainable Canadian Ag Partnership, the new 5-year FedProv framework. Where are things at in terms of advancing research in root rot? Of course, aphanomyces is top of mind for a lot of growers.
Over the last few 5-year programs, as you mentioned, the latest one being SCAP, root rot has more and more come to the center of those programs. It's a significant risk to pulse crop production across the country, and we're certainly seeing it here in Manitoba and on the prairies, most prominently with aphanomyces and that pathogen's infection of pea roots. And so there's a considerable effort being mounted in this current science cluster to address aphanomyces, both by figuring out its biology and by figuring out its genetics, and then thirdly by figuring out how its biology and genetics interact with the biology and genetics of the pea plant. So aphanomyces is a focus, but another focus that we're working on is a broader set of root rot pathogens, including fusarium. So a lot of people, they hear the word fusarium and think of fusarium head blight in wheat. In fact, the fusarium family of pathogens is very large, and they occupy the soil and create disease problems for the roots of beans, dry beans, and peas. And so in addition to a lot of aphanomyces work, we've got parallel work going on in a broader suite of pathogens, including aphanomyces. In those projects, we're connected in with federal and university labs stretching from Lethbridge to Guelph, and including work at Brandon and Morden. And so that's a key for us. We're part of a national effort on root rot. In fact, the 3 prairie provinces, the pulse groups there, have come together as a unified group to address root rot by co-investing in projects, and the science clusters is one area, but we're doing other things as well. It's quite a serious disease that we actually don't have a lot of solutions for right now. So we're working on the genetic front and the plant breeding front, but also on the agronomy front. We really don't know how many years you need to have between pea crops in Manitoba to prevent aphanomyces. We have an idea that it might be 8 years, but we're doing tests with the agronomist in residence program at the University of Manitoba to try and figure that out, and it's all linked into a very comprehensive focus on root rot.
Okay. You are also doing some work, of course, across the border in other areas with researchers at NDSU, for example. Is there some of that cooperation happening on the root rot front as well?
There will be, and certainly at the scientific level, scientists collaborate all around the world. So knowledge on genetics especially is shared, but when we come to putting those genetic knowledge to work actually on farms, we obviously share real estate with places like North Dakota and Minnesota. So we intend to forge relationships to the south of us, particularly with respect to dry beans and how root rot might affect dry beans. We've got a good collaboration west with our prairie cousins, and growing collaborations east with our fellow bean growers in Ontario. So now we're working to move south a bit, and together, this is what it's going to take. It's going to take some significant collaboration and some of the best scientific minds to figure this one out.
Yeah. And like you said, there's multiple steps to this chain that we don't have answers for. So there kind of needs to be that overview of somebody's a scientist somewhere or somebody in your position maybe that decides how do we prioritize research and where do we head with all these different pieces.
Indeed, a good example of that is that the existing resistance to aphanomyces is only partial resistance. So we don't foresee in the near future strong resistance. So in other words, we're going to have to rely on management, agronomy, and a bit of luck. And so while the geneticists are working on partial resistance and eventually full resistance. We have other folks working on the agronomy part and the soil science part and the management of soil water. And then we've got, hopefully some people working on the luck as well.
The luck, yeah. That's a tough one. Anything else then on root rot and where this project is headed in the next? It would be the next 4 years, I guess. We're almost till the first full year of the SCAP program already having gone behind us.
Yeah, we're hopeful we're going to see results from these projects, but it is a sort of behind the scenes kind of work for the time being, and so we're focusing at MPSG a lot on surveillance. So while scientists are working in their labs, you'll see MPSG agronomists around fields in Manitoba taking samples of soil, taking samples of plants, and collaborating with folks at Agriculture and Agri-Food Canada and the university just to track the extent of root rot, particularly aphanomyces, and just to keep a handle on that and to take notes on what kind of agronomic practices might be beneficial to managing this disease going forward.
Yeah. And farmers can, of course, participate in all of that surveillance as well.
Absolutely. In fact, it's required for it to happen. So every year we seek out growers that are curious about what root pathogens might be in their field, and we use biosecurity measures and enter fields and take samples. And this is for peas as well as soybeans, in fact. So we do a lot of that work in the summer and look to collaborate with any interested producer.
Okay. Well, thanks for your time again, Daryl.
Thank you.